Good afternoon, this is Shannon Gracie back again. Today we'll be covering section 3.3 from Sullivan and Sullivan's text, Precalculus, enhanced with graphing utilities. Okay, so here we go. You can go ahead and read our goals there for today. And we're going to start with a warm-up where we graph one of our library functions. So go ahead and pause the movie and warm it on up. Okay, let's see how you did. Here we have f and f at x. Just do a regular scale. You really need to know this graph quite well. We'll be using this in transformations, and we'll also use it for graphing parabolas using other methods. So here we are. We know that we'll have an ordered pair. Just for the heck of it, I'll write it out in case you've forgotten. So we're going to use symmetry on this. So if we plot 0, 0, 1, 2, and 3, we'll get a good feel for the graph. So f at 0 is 0 squared, which is 0. F at 1 is 1 squared, which is 1. F at 2 is, good, 2 squared, which is 4. And f evaluated at 3 is 3 squared, which is 9. So we'll have ordered pairs here, 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 and here. And then this graph, if you recall, is symmetric it's an even function, so it's symmetric about the y-axis. Now we'll learn a different term for this. This is actually the axis of symmetry, or line of symmetry, is right at that x equals 0 for this graph. So what that means is that the ordered pair 1, 1 is 1 unit to the right of the axis of symmetry. So we'll have 1 unit to the left, we'll have the same y value. And again, with this one, 2 units away, we're up at 4. And 3 units away, we're up at 9. And then we make the picture of our graph. And we're good to go. How'd you do? You do okay? Awesome. All right. Completing the square is a skill that we'll use when we're graphing quadratic functions using transformations. So this was why I put this warm-up problem. So if you recall, when you're completing the square, we basically are going to be adding 0 to the same side. So I'm going to leave a space because what we want to complete the square on are the x squared plus 6x terms. So if we go ahead and you add half of the coefficient to the middle term, and that is 3, and we'll be squaring that. Now we adjusted the equation by 3 squared, so we're going to have to subtract 3 squared, and the red in effect is adding 0 to this expression. So this will give us the quantity x plus 3 squared. That is what we engineered right here. That's equivalent. And then minus 1 minus 9, so we'll get x plus 3, the quantity squared, minus 10. And you've completed the square. Okay? All right. So next up, graphs like the one we just did are graphs of quadratic functions, commonly called parabolas. Parabolas open upward if the coefficient to the squared term is positive and downward if the coefficient to the squared term is negative. Parabolas have a fold line. That is, they have reflectional symmetry. So on the warm-up graph, it was at the line x is 0. And it's reflectional symmetry about a vertical line. This vertical line is found when you find the ordered pair where the minimum or maximum is located. This ordered pair, anybody remember what it's called? Good, it's called the vertex of the quadratic function. So a quadratic function is a function of the form f at x equals a times x squared plus b times x plus c, where a, b, and c are real numbers and a is not equal to 0. The domain of a quadratic function is the set of real numbers. Okay, so let's graph this one using transformations. So here, and I only gave you one graph to work with, so it might be a little messy, but let's take a look. So using transformations, basically we would be graphing one graph that would be your library function. So your first one would be y1 equals x squared. And then your second one would be y2 is 2x squared. And then your third and final graph, we'll do in red, would be y3 is equal to, actually not y3, but it would now be our function, is equal to 2x squared plus 4. So we already did the library graph, f at x equal to x squared in our, I'll just write this as x and y. We already did our library graph in our warm-up problem. So recall that you had an ordered pair at 0, 0, so our scale will be plus or minus 10. So 0, 0, 1, 1, we had symmetry going on. So I'm just going to dash in this graph here. This is just a basis for us to get started. So now what we're going to do for our, this is a little crooked here. So now what we're going to do is we're going to take a look at what happens when we double it. So that'll be the green. So if I double each y value, I still have a point at 0, 0. But instead of at 1, 1, I'll have it at 1, 2. And then using symmetry, I get this other point at negative 1, positive 2. And then instead of 2, 4, I'll have an ordered pair at 2, 8. And using symmetry, I get this one. So it's going to be a narrower graph. I didn't use that other ordered pair because we'd be off the grid. Okay, so now we'll do our final graph. So now I just need to move each ordered pair up by 4. So I'll have an ordered pair. Instead of at 0, 0, it'll be at 0, 1, 2, 3, 4. And then when I move this guy up, 1, 2, 3, 4, I've got that one and I've got this one. And then I think this one will be, it'll be off the grid, but we can sort of get an idea where it would land. So our final graph it looks like that. Okay? And so this is f at x is equal to 2x squared plus 4. So that's how we would graph this using transformations. Okay, so this one is going to be a little bit more difficult. So for this guy, we need to complete the square. in order to complete the square, you need to have a coefficient of 1 in front of the squared term. So f at x is equivalent to, you're going to factor out a negative 2 just from the first two terms. And then you'll complete the square. So yeah, you're going to be adding half of the middle term squared. So you're adding negative 3/2 squared. Now, negative 3/2, what we've really adjusted this by is we've adjusted this by negative 2 times that. Do you see? So what we need to do is this is going to, we need to basically add 2 times negative 3/2 squared to balance it, because we had this 2 times this. And this negative will, go away. So we have to have opposing signs. All right, so let's see what we get. F at x will be equal to negative 2 times the quantity, x minus 3/2 squared, plus 2, and then plus 2 times 9/4. So f at x will be equal to negative 2 times x minus 3/2, the quantity squared, plus 2 plus 9/2, because the 2 will divide out some of the 4. So f at x will be equal to negative 2 times x minus 3/2, the quantity squared. And then if we get a common denominator, that'll give us 4/2. So at the end of the day, we'll have plus 13/2. Okay, so here we go. So I'll just write this as x and y. And we're going to have a few transformations going on. So the first one, that we're going to do is our library graph. So we'll have our library graph. I'll just do, so y1 is going to be equal to x squared. So you've got your same graph that we've been working with. I'll dash this guy in. Now you're going to be multiplying each of those y values by negative 2. So it's going to reflect it across the x-axis. So your second graph, I guess I'll do this one in gray, negative 2 times x squared. So you still have 0, 0, but these are going to flip down here. And then this one, instead of at 2, 4, you'll be at 2, negative 8. And then by symmetry, you're over here. So you've got that shift. So now, I guess in green, I'm going to go ahead and I'm going to do that horizontal shift. So y3 is going to be negative 2 times quantity x minus 3/2 squared. So each of these y values, I'm going to move to the which way? Good, to the right by 3/2. So this is 3/2, remember, is 1.5. So I have an ordered pair here, and then 1.5, 1.5, 1.5, and 1.5. So I'm almost there. So now we have this graph. Okay? So now our last move, we'll do this guy in red again. So was it called f at x? Yeah. F at x will equal to negative 2 times x minus 3 halves, the quantity squared, plus 13 halves. So now each of the points from the green graph is going to move up by 13 halves, which is 6.5. So 1, 2, 3, 4, 5, 6.5. And then 1, 2, 3, 4, 5, 6.5. 1, 2, 3, 4, 5, 6.5. And then 1, 2, 3, 4, 5, 6.5. And 1, 2, 3, 4, 5, 6.5. So our final graph will be something like this. And so this is our f at x equals negative 2 times x minus 3 halves, the quantity squared, plus 13 halves. Okay, now let's consider any quadratic function, all right, of this format. So if you start from there, and if you complete the square, you'd need to factor out an a from the first two terms. So in order to successfully factor in a from this, you would have b over a times x, leave some space, and we still have plus c. So what I need to add is half of that coefficient squared. So b over 2a, the quantity squared. Now, what did I adjust this by? I adjusted it by positive a times that quantity. So what I need to do is subtract a times this quantity. All right, moving right along. What I created here is x minus b over 2a, the quantity squared, and then plus c minus a times b squared over 4a squared. Well, this a divides out one of those factors in the denominator, so we end up with f at x is equal to a times quantity x minus b over 2a, the quantity squared, plus c minus b squared divided by 4a. Getting a common denominator of 4a for the last two terms, we will have f at x is equal to a times quantity x minus b over 2a squared plus 4ac minus b squared all over 4a. Okay, so far? I know it's a little conceptual, but that's okay. You're going to be okay, I promise. So, looking at what we've got here, if we let h equal to b over 2a and k equal that last bit, so I have it here that we can write it in. So if h is equal to negative b over 2a, actually, let me make sure do I have my, you know what, my apologies. You might have caught this. This should have been plus all along. I did not have a negative. Okay, so we end up letting h equal to negative b over 2a, and k is equal to that second part, which was 4ac minus b squared all over 4a. Then what we have is this other format, f at x equal to, this is the original format we were working with, but that is equivalent to a times the quantity x minus h squared plus k, which you've seen before. So the vertex is the ordered pair, negative b over 2a, and then your function evaluated at that value. So if a is greater than 0, the minimum occurs, because it opens upward, so the minimum occurs at the vertex. And if a is less than 0, the maximum occurs at the vertex. All right, so here we go. Consider this function. It's already in that format for us, right? Because remember that general form, which you want to remember, is a times x minus h, the quantity squared, plus k. So a is good, negative 1, h is 3, and k is 6. So you've got all the pieces down. The vertex is h comma k, which is 3 comma 6. And you're done there. The axis of symmetry occurs at the vertical line that goes through the vertex. So x is equal to 3. Now the x-intercepts, we set the function equal to 0 and solve. So 0 equal to negative x minus 3 quantity squared plus 6. If I add x minus 3 quantity squared to both sides, I get this line. And then if you use that square root property, you get that x minus 3 is equal to plus or minus the square root of 6. So you get two results. So if adding 3, we would get x is 3 minus root 6, or x is 3 plus root 6. So let's get the calculator up, and we're going to get, so that's the exact answer for the intercept, but we're going to be graphing this, so we're going to want to be able to get an approximate. So 3 minus, if you go second, square root 6, enter, we get a 0.55. So x is approximately 0.55. And then over here, you can actually just hit second, enter to get that entry back, and then change the sign to a plus if you want to have a shortcut. And so that's approximately 5.45. So for this one, x is approximately 5.45. All right, so these are the x-intercepts. Find the y-intercept. If you evaluate the function at 0, you get negative 0 minus 3, the quantity squared, plus 6. So then f at 0 will be equal to, what would that be? Negative 9 plus 6. So f at 0 is equal to negative 3. So the y-intercept is at negative 3. And so now we have the pieces we need to sketch the graph. So here we go. We can just use our regular scale. So first off, the vertex. The vertex is at 3, 6. 3, 1, 2, 3, 4, 5, 6. I know it's going to open downward because A is negative 1. So that gives you kind of a hint if you're on the right track. Now let's plot our x-intercepts. They were approximately 0.55, 5.45. So what is this? 0.55 will be about here. And then 5.45, 1, 2, 3, 4, 5, a little lower. And our axis of symmetry goes down like this. So this is the fold line. And then we add in the intercept, y-intercept was 0, -3. So by symmetry, I get this ordered pair here. And then you just draw the picture of your graph, and you're all done. All right? I don't like that second one very much. Do a better job here. Okay. Okay, so that's an example of completing this, completing the square, or when something's given to us in that format where the square's been completed already, that's a great way to graph those graphs. But often we're given, these graphs in the form of f of x is equal to ax squared plus bx plus c. So when this happens, it's easier to use the fact that our h is -b over 2a, and then find k by evaluating the function at -b over 2a. So here's some properties. The vertex can be found by doing this. The axis of symmetry is x is equal to -b over 2a. So whatever x coordinate you get for the vertex is your how you make your vertical line for your axis of symmetry. If the parabola opens upward, a will be greater than 0, and the vertex is a minimum point. If the parabola opens downward, a will be less than 0, so the vertex will be a maximum point. And let's just take a look at the graphs we've done. So if you look at this guy, it opens downward, and you see the vertex right here. The vertex is the largest y value, largest function value you attain throughout the whole domain. So it's very important. It's very useful. And then this guy here, our vertex was the lowest value you attain. It was a minimum point, and you see that it opens upward. Okay, so that's something we'll be looking at. All right, so here we go. This is just to make sure you're good with finding the vertex. So if you want to pause the movie and try it out yourself, feel free. Otherwise, work along with me. Okay, so this first one, so -b over 2a is equal to b is -12, and then a is 3. So this, when you do the algebra, you end up getting +2. Evaluating the function at +2, we get 3 times 2 squared minus 12 times 2 plus 1. So f at 2 is, what's that going to be? 12 minus 24 plus 1. So f at 2 is -11. So what did we find? The vertex is at the ordered pair 2, -11. Now, will that be a maximum or a minimum point? Good. A is 3, which is positive, so that'll be a minimum point. All right, so here we go. I'll write that in. Okay, so here we go. Next up, -b over 2a is equal to negative. So b is 7, and then a is -2. So we will get +7/4. Evaluating the function at 7/4, we'll get -2 times 7/4 squared plus 7 times 7/4 minus 4. Crunching through the algebra, we will get -2 times 49/16 plus 49/4 minus 4. This 2 divides out some of the 16. So the LCD for this fraction is going to be 8. So this guy does not need to be adjusted. This guy here needs to be multiplied by 2/2, and this one needs to be multiplied by 8/8 to get a common denominator. So we'll get plus 98/8 and then minus 32/8. So f at 7/4 will be, at the end of the day, we get 17/8. So what did we find out? We found out that our vertex was at 7/4, 17/8. So is that point a minimum or maximum point? Good, it's a maximum point since we have a negative coefficient to the squared term. Okay. Now part C, don't multiply it all out. You've been given the format. Remember that one format, f at x is equal to a times x minus h, the quantity squared, plus k. So that tells us that h is 2 and k is 12. So your vertex is at 212. And that is a good minimum point. Since a is -3, which is less than 0. No, maximum point. Remember, stop me if I'm making up my own math. So maximum, since we have a negative value, so it's opening downward, so that'll be the maximum. Very good. Okay, so moving right along. This is just more practice graphing. We're going to use the, since it's not factored for us, in that other format, we're going to use the formula. So to find the vertex, -b/2a is -8/2 times 3. So I think we get +4/3. The function evaluated at 4/3 is 3 times 4/3 squared minus 8 times 4/3 plus 2. So we'll get 3 times 16/9 minus 32/3 plus 2. So f at 4/3 will be, let's see, this 3 divides out some of the 9. So we'll have 16/3 minus 32/3. And then getting a common denominator for that 2, we need to multiply by 3/3. So we'll get 6/3. So f at 4/3 is, I think, -10/3. So our vertex is at 4/3, -10/3. Okay, so far? Awesome. All right, so what is the axis of symmetry? So easy, it's hard. X equals the x-coordinate of the vertex. So x equals 4/3. You can't just put 4/3, otherwise it's not a vertical line. X equals 4/3 means a vertical line when answering this question. So find the x-intercepts. So you need to find the zeros of the function. So 0 equal to 3x squared minus 8x plus 2. I'm going to use the quadratic formula. So x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So x will be positive 8 plus or minus the square root of 64 minus 24. Oh, my bad. A was 3, so 2 times 3. So that's over 6. So we're going to get x is equal to 8 plus or minus root 40 all over 6. So x will be, we reduce that 40, 4 times 10 is 40, so you end up getting 2 root 10 over 6. So we will have x is, you can factor out a 2 from the numerator, and you're going to get 4 plus or minus root 10 over 6. 2 divides out itself and sum of 6. So x will be either 4 minus root 10 over 3, or x is 4 plus root 10 over 3. So again, we're graphing, so we're going to want to get approximations. Be careful when you're approximating. If you do this all at once, you need to put parentheses around the numerator. So this is what I mean. You need to do parenthesis 4 minus square root of 10. One parenthesis ends the radical and the other ends the numerator, and you're dividing the whole thing by 3, and you hit enter, and we get approximately 0.28. And then over here, I'm going to do that trick where you can do second entry. So I'm going to say second enter, and then I'm going to just go back and change this to a plus. And we get approximately 2.39. So that's going to help us for graphing. Okay, so find the y-intercept. The y-intercept is when you evaluate your function at 0. So our function evaluated at 0 is 3 times 0 squared minus 8 times 0 plus 2. And you see that f at 0 will just be 2. And now we just sketch the graph now that we did all the prep work. So I'm just, I'm going to do a scale of 5 all around this time because we had some smaller numbers. So each of these tick marks will be a half a unit. And this was f at x and x. Okay, so first off, graph the vertex. So 4/3, negative 10/3, so 1.5 is here, so 1 1/3 is about here. And then 10/3 is 3 1/3, so we're going down to about here. Actually, let me see, 1 2 3.5. It's going to be a little closer. It'll be about here. So that is our vertex. This guy has a positive a. It's a equal to 3, so it's going to open upward. And let's go ahead and dash in our axis of symmetry. So it'll be something like this. And then what else did we have? We had ordered pairs at about 0.3 and 2.4. 0.3 and 2.4 for the x-intercepts. And then about right there. And then our y-intercept was going to be at 2. So 1, 2. And by symmetry, this is 1, 2, and third. So 1, 2, wait, 1. I can't count today. Let's see. 1. It'll be about here using symmetry. So then when we just draw the picture of our graph, and we're good to go. Okay? Fun times, graphing parabolas. All right, so here we go. This one, is one of those deep thinker problems. So here we go. It's kind of a multi-step problem. We've been given information. We've been given that a couple of ordered pairs on the graph. So I'm going to just go ahead and I'm going to start out by using the fact that -1, -8 is an ordered pair on the graph. So that'll be my first step. So my first step is going to be, I'm going to let f of x be -8, and then I'm plugging in -1 for x. So we'll have a times -1 squared plus b times -1 plus c. So this is what I plugged in for x. And then for f at x, we plugged in -8 for the whole function value. So this gives us -8 is a minus b plus c. Now, I'm going to be getting information about A and B from the vertex information. So I'm going to go ahead and I'm going to isolate C. So with a little algebra, I would get that C is equal to -8 minus A plus B. I basically subtracted A from both sides and added B to both sides. So we have C that's written in terms of A and B. Now, second step, we know that -b over 2a is equal to 1 because we've been given the vertex. So if I were to isolate b in this equation, I would get -b is 2a, so positive b is -2a. So we're going to just keep that in mind. We're just working at it step by step. Now, thirdly, remember that sort of mean-looking equation for k. So k, which is 4, is going to be equal to 4ac minus b squared all over 4a. So from that information, what would we get? 16a is equal to 4ac minus b squared. So if I were to, I'm just going to get, we're going to do a couple of things now. Let's go ahead. Remember what b was. Remember b was equal to -2a. So in for this b squared, I'm going to put -2a. And in for this b, I'm going to put -2a. So I'm going to start up here. C is -8 minus a minus 2a. So C is going to be -8 minus 3a. So now we can write this equation in terms of a alone and solve. So we'll have 4a times negative 8 minus 3a, and then minus b squared. So b was negative 2a, and we're going to square that. So we'll get 16a is negative 32a minus 12a squared minus 4a squared. So getting 0 on one side by subtracting 16a, we're going to get negative 48a minus 16a squared. So we can factor out a negative 16a to solve this, and we'll get 3 minus a. Actually, it'll be 3 plus a. So then you either get negative 16a is 0 or 3 plus a is 0. A would be 0 in this case, but we're going to throw that out because then we wouldn't have a quadratic. So we're going to keep this one, a is negative 3. Then you just plug stuff back in. So we have a is negative 3. So b is negative 2a. So that'll be b is negative 2 times negative 3. So b is going to be 6. And then c was negative 8 minus 3a. So c will be negative 8 minus 3 times negative 3. So c will be, let's see, what's that going to be? Negative 8 plus 9, so it'll be 1. So at the end of the day, a is negative 3, b is 6, and c is 1. Okay. Steps for graphing a quadratic function. Option 1, you can complete the square and write the function in this format. And then you graph the function in stages using transformations. So the second option is determine whether the parabola opens up, so a would be greater than 0, or down, a would be less than 0. And then determine the vertex by finding negative b over 2a and evaluating the function at negative b over 2a. Determine the axis of symmetry is going to be x is negative b over 2a. And then find the intercepts, the x-intercepts, if any, and the y-intercept. By evaluating f at 0. And remember, this guy means you set f at x equal to 0 and solve for x. So if b squared minus 4ac is greater than 0, you're going to have 2 x-intercepts. If b squared minus 4ac equals 0, the vertex is going to be your x-intercept. So you'll only have 1. And if you get a negative under that radical when you're doing the quadratic formula, meaning you get a negative here, there are no x-intercepts because they'd be imaginary solutions. So you can determine an additional point using symmetry with that y-intercept. And then you just plot the points and sketch your graph. Easy peasy. Okay, so here's a couple of applications that deal with parabolas. So find the point on the line y equals x plus 1 that is closest to the ordered pair for 1. So what do we know? We know how to take a function and write it in x alone, right? So remember the trick here, if you use distance of x squared is going to be equal to, so we have these ordered pairs. We have the ordered pair for 1, and you see we have the ordered pair x, y, which is x comma x plus 1. Okay, so far? Because of this information here. So the distance formula, when we do use this, is going to be x minus 4 squared plus x plus 1 minus 1 squared. So your distance in terms of x squared is going to be x minus 4, the quantity squared, plus this simplifies to just x squared because the 1's zero out. So distance in terms of x squared is, when we multiply this out, remember it's x squared and then minus double the product of the ends. So 2 times x times 4 plus 16 and then plus x squared. So we'll get this parabola. So we'll have 2x squared minus 8x plus 16. So remember that this is going to open up, so the minimum point is going to be the vertex. So here all we need is the input value of the vertex, so the x coordinate, and once we get that result, we will have found the minimum distance, and we will then plug it into y equals x plus 1 to find the point that's on the line that's closest to 4, 1. So here we go. Negative b over 2a equals negative 8 over 2 times 2, and that is equal to positive 2. So now plugging in positive 2, we're using this point here. So the ordered pair x comma x plus 1, we found that x would be 2, and we'll get 2 plus 1. So that is equal to 2 comma 3. So 2, 3 is the point on the line y equals x plus 1 that is closest to 4, 1. And you're done. Good. Okay, so lastly, the John Deere company has found that the revenue in dollars from sales of riding mowers is a function of the unit price P in dollars that it charges. So if the revenue is R at P equals negative 1/2 P squared plus 1900 times P, what unit price P should be charged to maximize revenue, and what is the maximum revenue? So again, if it's quadratic in form, so negative b over 2a is going to give us the answer to the first question. So we'll have negative, so b is what? 1900 divided by 2 times negative 1/2. So that's just equal to 1900. So $1,900 is the unit price that will yield the maximum revenue. So now what is the max revenue? Well, R evaluated at 1900 gives us the maximum revenue. So that is negative 1/2 times 1900 squared plus 1900 times 1900. So we will get R at 1900 is, so this we'll just punch it in on the calculator. Let's see, so we had negative, I'm going to just do 0.5 for our 1/2 times 1900 squared plus 1900 times 1900, enter. So 1,805,000 is the maximum revenue. So let's answer the question. A unit price of $1,900 yields the maximum revenue of $1,805,000. And we're done with this section, I think. So have a fabulous day. Don't forget to do some of your problem set to get these skills seared into your mind. All right, bye.